Okay, so the synthesis build flow completed, finished. Said something down here about succeeded. That's always good. So in this video, we're going to poke around at some of the results, the outputs, the artifacts. Hop into Libero, and see what's going on there. All right. So first of all, I wanted to find out where the artifacts were hiding. So I didn't quite know what to look for. So I went over here in my downloads folder and I looked and I unzipped the artifacts and I got this gateware and I said find gateware. And I saw all the files that were there and I said, okay, well, what can we look for that might help us give us a breadcrumb on the other side? So I said, okay, job. And so I went and I said, let's go and find dot and grep job. And when I did that, came up with some files and it said, oh, it's in Bitstream, Flash Pro Express. Ooh, that looks really close. Look at this, Flash Pro Express. My custom design, something.job. Something my custom design with a different number, some job, digest. And so I said, okay, let's find everything that's in Bitstream. There we go. Gee whiz, those look awfully the same. So I'm thinking that all we need to do is copy recursively or SCP recursively bitstream over to the, uh, the board, and similar to where it's called my custom FPGA. This time it's just called bitstream. Guess I could copy it or move it, but get this guy up and over, and then that would work. Not going to do that right now, but I'm pretty sure that'll work. So I'm feeling pretty good that bitstream is easy to get to. So now let's go in and so let's also do a find dot prjx. So what we're looking for is a prjx file, which is the Libero um, project file. And so that is, let's go where we are. So we're in cFire, gateware serve on fire. And so let's try to bring up this Libero thing right now. And let's see how it does. I don't know if we can put it in the background. I'm not sure. Let's just leave it on. All right, so it's popping up. And so we've got the paths set up and everything. And it says here, do you want to check for updates? And no, thank you. And now we want a project, open project. Let's go to C Fire. Geyser on fire. Does it work? Libero. And then, yeah. Double click. There's 3 dots. All right. And so this is loading the design. And let's just do a little walkthrough. So it comes up with this. The guy who's in dark here, that's our top level design in the hierarchy. And so you can start off, and it's very important here. So we got this design hierarchy. We also have these other tabs. So we have the design flow tab, and this is where everything gets synthesized. You can see these little check blocks along the way. That means that those were all successfully done. So it successfully synthesized the design, did place and route where it took the gates and it picked which gates to use and what routing channels to use to connect them. And then we did a verification on timing to see how that looked. Um, And then we went and we defined some things about the memories, and then we went and we generated the bit stream. And then from here at this point, if you were using your Flash Pro 5 or 6, you would double click on this run program action, and that would go and it would program your board. Um, yeah, so this is this tab. There are other tabs. So this design hierarchy tab is got your hierarchy. And also, so like, let's go to this My Custom FPGA, the one that's in dark, bold. And that, when I double clicked on that, left double click, this gives you the design in here. So you can see that there's 4 big blocks, all connected with by various wires. The dashes that you can see, yeah, those dashed lines are like bidirectional signals, so they can go input or outputs. Um, yeah. So what you can do in this guy is, I tend to use the middle scroll wheel a lot. Um, 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 Make me a liar. All right. Okay. So, if you press the control button on the keyboard and then you roll your scroll wheel, you have to scroll in and out like this. If you press the shift key and scroll, you go left and right. If you press, if you don't press anything and you scroll up and down. So let's do press the control. Oh, look at that. Let's um, press the control and scroll in. And then I'm going to let go of the scroll of the control. And then I'm going to scroll up. And so this here is the BVP RISC-V subsystem. And so this has got your processor cores in it. If we scroll out again, and here we've got the M2 interface. That's what plugs up to our Wi-Fi. And here we've got the cape with all these bidirectional signals going in and out of the cape. And so those are all the signals that we can connect to. Um, yeah. So say you wanted to go into, oh, I don't know. Let's 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 say let's figure out how fast the cape's clock is running. So how many megahertz is it running? So we've got these inputs of we've got this P clock right here. So you can click on P clock, left click, then right click and say go to driver and left click. That takes you to here. We wanted to scroll out. You press the control button, scroll, and you scroll out. And so this signal that we were just looking at is going to FIC, which is like, I don't know, fabric interconnect or something like that, 3. And that is what PolarFire, the third, the FIC3 is used for the APB bus, which is a slow bus that usually goes to like slower speed peripherals. It's still pretty snappy. It's running at some fast clock rate, which we're going to find out in a moment. But yeah, so we've got this FIC3 P clock. So now then, if you double clicked on this clocks and resets, FIC3, remember that. Boom. All right. It takes you in, and this is so this is the clocks and reset block. It's open another tab. So you can still go to this first tab, and you can open up where you had just left off on the hierarchy on the My Custom FPGA design. But we still got, so we got clocks open here, and now we're looking for FIC3 P clock right here. And you can slide over, and that's going from this clock conditioning core. I think that's what CCC stands for. And so this one's taking in some sort of ref clock. Let's see what it's got for a ref clock. And so they have a built into the FPGA SoC an oscillator, and this oscillator is toggling at 160 megahertz, and its output is going up and over and going into this clock conditioning block. So now what we're kind of interested in just is FIC3, that's this guy here. He's going to out 3 of this clock conditioning block. So remember that, out 3 VAB clock, out 3. Now you double click on that. We just double clicked on the CC. And so this drops us into here. And this is like a pre-built design block provided by BeagleVFire. And it's you can configure it. So they've got a input frequency of 160 megahertz. That was that oscillator that we just saw. So that's going into it. And then, so that's on the clock options PLL. Now you click on the outputs, and we've got 1, 2, 3, 0, 1, 2, 3, of which we saw that we wanted to have the third output, output 3. And so output 3, they're configuring it. So let's take that 160 in. They will do some like a multiply and a divide to get to 50. And so what ratio? So they're doing the math for us. You just dial in 50, and then it'll do all the math. But there should be some multiple that gets you from 160 to 50. So 160 times 2 is 320. Times 2 is 640. Well, I can't quite figure it out in my head. Maybe you can, but we don't need to because they figure it out for you. You just dial in that you want 50. And then if you can get to it, it will say, okay, so the actual lower is going to be 50 megahertz right on the money. Actual higher is going to be 50 megahertz right on the money. So we've got, so it was able to come up with derive a 50 megahertz clock. So the serve that we were running that was doing the blinky a couple videos ago is running at 50 megahertz. And so that's how you can figure out your clock. There's what other interesting things are we going to do here? So um, let's see. So let's go back over to, scroll out. Where's it hiding? This guy here. Let's come back in again. And right here is the APB bus. And so sometimes it's kind of interesting to know what address ranges things are living at so that you can know how to access some of the software. And so it's coming in on the Cape APB M target on the BVF risk subsystem. So let's remember that the Cape APB M target. So let's double click on this. So what took us in here, just to get a handle on the names. This is the BeagleVFire SoC MSS. So this is a primitive. We'll take a look at that in a moment. We got this FIC initiator, and that's probably the block we'll end up at. And it's just to see what else is there. We've got I don't know what the IHC is. We got some sort of APB arbiter. We're not quite sure what that'll be doing yet either. But what we want to do is we want to find the, what was it called? The Cape APB M target. So let's go back over to here. Now, with this IDE, I have not yet really found a good way to search for stuff, but you can still find it the old-fashioned way. It's not too bad. So this is the Cape APBM target, and that goes in and it's going over to this initiator. You can see hanging off of it, there's one APB bus going into it, and 4 are going out of it, of which we have them numbered 1, 2, 4, and 16. Remember that. On one, and the one is the one we're interested in. So double click on this guy, the FIC initiator. All right, so this is a core that you're allowed to configure, and let's see. It's a 32-bit bus. It has the number of address bits going into it is 28. So it's like from 20 bits 27 down to 0. The position for the addressing of the upper 4 bits is 27 to 24. So those 4 bits range from 0 to 15 or 0 to F hex. And so these are these slots right here. And you get to select which slots you want to have active. So which ones actually you want to have an interface going out of. And so in this case, we were using slots 1, slot 8, and slot 3. Interesting. Interesting. I didn't quite expect that. Oh, interesting. How does this work? So those are the slots. Yeah. So these slots line up for like with these 4 bits. If these 4 bits were 0, that would activate slot 0. Um, oh, I'm sorry. Oh, okay. All right. I had the order upside down. So the top one is the ones that they want to combine. So in this case, they're combining slots, anything that's like with, if those 4 bits were a 3 or an 8, then what that will do is that will assert a combined bit, enable bit coming out of it that would be going out, and that would activate this 16. So like we got 0 through 15, and then the 16th one is where they're combining things. So they can see, you can click on this guy, slot 3, and so if it's ever a 3 or an 8, those combine to activate this port, peripheral port 16. And then if you want to enable specific ports, you can enable slot 1, which is enabled here, and enable slot 2, which is coming out here, and we skip 3 because that's a combined slip, and then we got slot 4, which is coming out here. So basically, if we ever want to activate this line here, why can't we select it? Well, this line here, that top one, we need to have a 1 in bits 27 to 24. Let me get back to where we were. Is it mad at me? Not too mad at me. Sure, it's got to be somewhere. There it is. For here. Here's hiding on this. Okay, so and usually, so what I know from some other stuff is the most significant nibble at 28 to 31, or 31 down to 28, has to be a 4 in order to activate FIC3. That's hidden in some documentation somewhere that we can someday maybe look at. So we need to have a 4, and we also need to have a 1. So we need the top byte needs to be a 41 in order to get to any of the CAPE registers. So 41, and then usually like the lower bits are decoded. However, we put in our decode logic down there. Yeah, so that's kind of how you can piece together how what the address range is. So from anywhere from 41 XXXXXX down up to 42 XXXXX minus 1 would be go get the range for our cape. Um, let's see. So we're sliding in. Um, yeah. What other interesting things that are worth looking at? Um, So a little bit seems a little bit mad at me. I don't know why. I don't know. It's not entirely thrilled. See, these are grayed out. Why are they grayed out? What's it doing? Does it think it's running something? Usually the grayed out means that something is running. Huh. I don't know. Hmm. So we should be able to. I want to. Well, let's go back just for for fun. Let's go back to this risk. And so the most configurable block that we've got is, wait, it's really mad at me. Why do I just shut this down? Oh, there we go, because this guy's popped up behind it. Lovely. Um, let's bring this back up. No longer mad at me. See, everything's green instead of gray. Two things I want to take a quick look at is that in the risks V subsystem, zoom out, and here is the big block, which is the PF SoC Polar Fire system on chip microprocessor subsystem. And so double click on that. So this is a configurable macro, so you can enable different peripherals off of the MSS. And so we're taking a quick look at this. Um, so what this is opening up MSS configurator, but since it's in this mode when you call it from Libero, for whatever reason, this is going to be opened up in read-only mode. So you can see here things that have been activated. You can um, so you can configure your DDR. You can change like the data widths and other things for different boards. So this has probably been configured up just for the, the Beagle the BeagleV. You can configure your cache. You can configure addressing from and to the FPGA fabric. So in this case, they are enabling FIC0, FIC1, FIC2, and FIC3. They got checkboxes on all of those. Um, You can enable like the clocks. So you can see here in this picture here, they've got a 125 megahertz clock going into it, a 600 megahertz clock coming out of it. And so the cores are running at 600 megahertz. The AXI bus, which is the high speed bus, is running at 300. And the AHB APB is running at 150. And in reality, it's running at 50 because of that clock that we saw. Um, so the bus is probably running. I think that the interface to the processor side of the bus is running 150, and then the side on the fabric side is running at 50. Yeah, so this is kind of showing a diagram of all the clocking. Um, So these are some of the MSSIO pins. Whenever you got a signal, like a pin with the MSSIO, those are dedicated just for the MSS. So they're pins that are hardwired directly to the MSS and do not go to the fabric, and the fabric can't mess with them. There's a lot of signals that come from the that come from the MSS, go through the fabric and then to pins. So those are a little bit more flexible, so that the fabric or the MSS can control them. And then there are other pins that are just going to the fabric. Um, so this is just basically talking about those signals. Some memory partitioning. It's miscellaneous. Yeah. So basically, this is all configured with like the NSS configurator. Um, and so there's that. And I think it's probably in this grand scheme of things, I'll be really want to take a look at. This is uh, just to get our toe touched into the water of Libero. Um, Seeing if there's anything else that we want to kind of touch on. Um, yeah, I think so. I think we're just going to call it from here. Uh, Archive. Oh, one more thing is that sometimes I can't quite see it here. Sure. Thought I wanted to minimize. No, I wanted to minimize it. Let's minimize him. And so I think I wanted to. Let's shut him down. He's hogging up. Um, let's see if find. Um, you'll notice that I use the find command a lot. I never know where anything is, but with that, I can usually remember just enough of a file name to try uh, open or successfully open it up or find it. Um, Here we are. Uh, let's see what make an account. LibreOffice account. Let's open him up. See what does. So this is similar to Excel. We want to find, open um, this PC, C, fire. Here's fire. Here's fire. Um, we put it at a gateware serve. That's what we're looking. And so we want the synthesis synlog report. Let's see. There. Synthesis synlog report. A little wider. All files. And we're looking for fire right here. So we're going to open up this higher area. So this will show us for each level of hierarchy how many gates and FPGA resources are being consumed. So I'm kind of interested in, particularly interested in how big is that serve processor. So we should be able to find it. Here's the cape. Here's Servant. Right here, Servant takes up 272 resources. Here's Serve Top Mini. Swap. And so that takes up 163 look, logic gates. So what is that? So we're at 163 gates. Let's just go back and see how we did compared to the rest of the world. So let's go to GitHub. Mm, There we go. And he gave some stats here. So on the Lattice, on the Intel, it's using like all these guys are like 164. That looks awfully familiar to 164, and then we have the number of resources ranging up to 239 there. And if we went back to here, we've got 163. So somehow I used one less flip-flop. I don't know how. And 256. So 256, if we go back to the web page, 256. So we're uh, kind of on the high end as far as like the other resources go. But the flip flops come in about right. Um, so that's, I guess, in a nutshell, you can poke around, you can see reports, you can see area, you can review timing, you can do a lot of things but when you're able to actually run Libero on your local machine. I think I'll call it there. Bye bye.